The cosmos is a place of profound and unsettling secrets. We are about to journey through 30 cosmic discoveries that defy logic and challenge the very foundations of our reality. These are not just scientific curiosities, they are fundamental cracks in our understanding of the universe. By the end, you will possess a new perspective on the deepest enigmas hiding in the void of space. We will confront a signal from the stars that has never been repeated and a force pulling entire galaxies toward an unseen horror. What single cosmic mystery makes you question everything you thought you knew? It was a quiet summer night in 1977. A routine scan of the cosmos from the Big Ear radio telescope at Ohio State University. Astronomer Jerry Amon was reviewing pages of printed data, columns of letters and numbers representing the faint radio whispers of the universe. Then his eyes locked onto one sequence. A burst of intensity so powerful that he circled it in red pen and wrote one word beside it. Wow, that single 72-second signal, arriving from the direction of the Sagittarius constellation, remains arguably the most tantalizing and frustrating event in the history of the search for extraterrestrial intelligence. It was not random static. It was a focused, narrowband signal on the specific frequency of 1420 MHz, a frequency that is naturally silent because it is protected by international agreement, a quiet channel reserved for listening to the cosmos. Think of it like tuning a radio across a crowded dial through all the music and chatter, and suddenly finding one station broadcasting a single, pure, and impossibly strong note of a specific pitch before it vanishes forever. The signal's intensity rose and fell over exactly 72 seconds, the precise signature expected for a distant, fixed source passing through the telescope's stationary gaze. This was not a passing satellite or a stray human broadcast. Every conventional explanation has crumbled under scrutiny. It was a shout from the void that has never been repeated, a one-time cosmic event that defies all logic. Was it a natural phenomenon we simply do not understand, or was it something else? A fleeting message, a beacon, a ghost in the interstellar machine that continues to haunt our search for other minds in the great, dark ocean of space. The WOW signal is a ghost from our cosmic neighborhood, a whisper from just one direction. But what if the entire universe is being pulled, a slow, relentless river of galaxies flowing toward a destination we cannot see? This is dark flow, and it is perhaps the most unsettling large-scale motion ever detected. For decades, the bedrock of cosmology has been the cosmological principle, the simple, elegant idea that on the largest scales, the universe is uniform. No single place is special. Look out in any direction, and the grand cosmic tapestry should look essentially the same. Dark flow shatters that assumption. Astronomers mapping the cosmic microwave background, the faint afterglow of the Big Bang, noticed something impossible. Hundreds of massive galaxy clusters, each containing thousands of galaxies, are not moving randomly. They are streaming, they are all flowing in the same direction at staggering speeds of over 2 million miles per hour toward a single point on the sky, a cosmic attractor that lies beyond the edge of everything we can observe. Think of it like floating in a vast, calm ocean. You expect to drift with the local currents, but then you notice every single piece of debris, every distant ship, every floating leaf is all moving in one concerted direction, pulled by a colossal waterfall that exists beyond the horizon. The force required for this is unimaginable. It is not dark energy which pushes the universe apart. It is not dark matter which provides the gravitational scaffolding for galaxies. This is something else entirely, a gravitational pull from a structure so vast it defies our understanding of cosmic architecture. The only logical source for such a titanic tug is a concentration of mass billions of times larger than our own Virgo supercluster. But according to our standard model of cosmology, such a structure could not have formed in the time since the Big Bang. there has not been enough time for gravity to assemble something that big. So what is it? One terrifying possibility is that this flow is evidence of something beyond our observable universe. Perhaps it is the gravitational influence of another universe, a parallel cosmic bubble brushing against our own in the greater multiverse. Or maybe it is a relic from before our own Big Bang, the remnant of a previous universe, a celestial corpse whose immense gravity still tugs at the fabric of our newborn cosmos. Dark flow suggests that our universe is not an island. We are not alone in the greater metacosmic ocean, and we are being pulled toward a shore we cannot yet see. Dark flow reveals a current sweeping entire galaxy clusters toward the unknown, but this cosmic river has a more local and equally mysterious tributary. Our own Milky Way galaxy, along with its neighbors, is caught in a specific, relentless pull toward a single point in space, a place astronomers call the Great Attractor. This is not a distant, theoretical flow. This is our home being tugged through the void. For decades, the nature of this attractor remained a profound puzzle because it lies in a direction that is notoriously difficult to observe, hidden behind the plane of our own galaxy. This region is known as the zone of avoidance, a dusty, star-filled shroud that blocks our view of the distant universe beyond, like trying to see a distant mountain range through a thick, perpetual fog. The sheer amount of cosmic dust, gas, and brilliant stars in this zone obscures almost all the visible light from objects behind it, creating a giant blind spot in our cosmic map. Yet, gravity cannot be hidden. We know the Great Attractor is there because we can feel its pull, a force so immense it is drawing our entire local group of galaxies and thousands of others toward it at a breathtaking speed of over 1 million miles per hour. What could possibly possess such gravitational authority? Initial calculations suggested a mass equivalent to tens of thousands of Milky Way galaxies concentrated in one region. But what was it? A single, unfathomably large galaxy, a dense knot of dark matter, or something else entirely? The quest to unveil this hidden monster required new eyes, telescopes that could see through the cosmic fog using wavelengths other than visible light. Radio and infrared telescopes began to pierce the veil of the zone of avoidance, and what they found was even more staggering than a single massive object. They discovered that the Great Attractor itself is merely a waypoint, a suburban outpost of an even larger structure, the incomprehensibly vast Laniakea supercluster. Our entire local group, including the Milky Way, Andromeda, and dozens of smaller galaxies, is just one tiny part of this cosmic continent, and we are all flowing toward its gravitational center of mass, a point near the Great Attractor. So the mystery deepens. The pull we feel is not from one hidden monster, but from the collective gravity of an entire supercluster of galaxies, a web of dark matter and brilliant islands of stars on a scale that the human mind can barely comprehend. Yet even this realization does not fully settle the account. The initial measurements of the Great Attractor's pull seemed almost too strong, hinting that there might be something even larger, something beyond Laniakea, still pulling us onward into the darkness. Even as we are pulled by the gravity of Laniakea, another cosmic mystery demands our attention, one that flickers with an intelligence all its own. A star known as KIC 8462852, or more famously as Tabby's star, behaves like no other in the known galaxy. Nestled over 1,000 light-years away in the constellation Cygnus, it was the Kepler Space Telescope that first noticed its bizarre signature. While Kepler was designed to find planets by detecting the tiny, regular dips in starlight that occur when a world passes in front of its sun, Tabby's star presented something entirely different. Its light did not dip in a predictable, gentle rhythm. Instead, it plummeted by staggering amounts, up to 22%, in chaotic, sharp, and asymmetrical patterns. This was not the fingerprint of a simple, spherical planet. This was the signal of something vast, something complex, and something utterly unknown blocking its light. Imagine watching a familiar street lamp every night. Most nights it shines with a steady glow, but on some nights its light flickers and fades drastically, as if colossal, irregular shapes are drifting past it, blocking its light for days or even weeks at a time. This is what astronomers witnessed. The initial and most natural explanation was a colossal swarm of comets, but the energy required to produce the amount of dust and debris needed to dim the star so severely defies plausibility. The comets would need to number in the millions, a swarm of unprecedented scale, and their irregular orbits do not fully account for the precise, deep dimming events recorded over years of observation. With natural explanations straining, a more spectacular possibility emerged, one that captures the imagination like few others in modern astronomy. Could we be witnessing the construction of a Dyson sphere, a hypothetical alien megastructure designed to encapsulate a star and harvest its entire energy output? The irregular dimming patterns could be explained by vast, incomplete swarms of collectors orbiting in complex formations, their passing shadows creating the bizarre light curve. While scientists are deeply cautious, the idea persists precisely because no conventional model has yet been able to fully explain the data. The star has continued to behave erratically, with new and unexpected dimming events observed by telescopes around the world, each one adding another layer of intrigue. The latest data suggests the dimming is not caused by opaque, solid objects, but by something far more ethereal, a fine, opaque dust that somehow clusters in these strange, unpredictable ways. Yet, the source of this dust and the mechanism that arranges it remains one of astronomy's most compelling open cases. Tabby's star stands as a permanent reminder that sometimes the most logical answer is that we are simply missing a fundamental piece of the cosmic puzzle, a piece that may forever change how we view our place among the stars. The erratic flickering of Tabby's star taunts us with the possibility of intelligence, but the cosmos responds with a much deeper, more unsettling silence. This silence is the heart of the Fermi Paradox, a contradiction so profound it forces us to question our entire understanding of life and reality. If the universe is so vast and so old, with billions of Earth-like planets, then where is everybody? The numbers are overwhelmingly on the side of life. There are more potential homes for life in our galaxy than there are grains of sand on every beach on Earth. The cosmos should be teeming, buzzing with alien civilizations, their signals crisscrossing the void. Yet when we listen, we hear nothing but the natural radio hiss of stars and gas clouds. It is a silence that screams. One chilling explanation is the concept of the Great Filter. This is the idea that at some point between the emergence of non-living matter and a species colonizing the galaxy, there exists a barrier, a step so difficult that almost every civilization fails to pass it. The terrifying question is, where is this filter located? Is it behind us, something we have already miraculously survived? Perhaps the jump from simple prokaryotic cells to complex eukaryotic life, a transition that took over 1 billion years on Earth, is so astronomically rare that it is the filter. Or is the Great Filter still ahead of us? Could it be that every advanced civilization eventually discovers a technology, perhaps in particle physics or artificial intelligence, that inevitably leads to its own destruction? The silence of the universe in this light is not a sign of our solitude but a graveyard warning. Another possibility is less violent but equally isolating, the zoo hypothesis. Imagine a vast cosmic wilderness preserve, and Earth is one of the protected planets. Advanced civilizations know we are here, but they adhere to a strict policy of non-interference, observing us from a distance to allow our culture and technology to develop naturally without their influence. We are the exhibit in a galactic museum, and the rules forbid the exhibits from knowing they are being watched. This would explain the silence, but it also implies a level of universal coordination and restraint that is difficult to fathom. Then there is the final, stark possibility, the one that defies all the probabilities. What if we truly are the first or the only? What if the combination of factors that led to our existence, from a stable star to a large moon stabilizing our axis to the precise chemical makeup of our planet, is so exceptionally rare that it has only happened once in the entire observable universe? In this scenario, the silence is not a mystery to be solved. It is the natural state of a cold, empty, and lifeless cosmos, and we are its only thinking, feeling witnesses, a solitary voice in an infinite, unhearing dark. The answer to the Fermi Paradox, whatever it may be, holds the key to our ultimate fate, locked within the profound and unbroken quiet. The profound silence of the cosmos is suddenly and violently broken by a scream. Lasting only a few milliseconds, a flash of radio energy erupts with the power of 500 million suns. These are fast radio bursts, and they are one of the most energetic and perplexing phenomena in the modern universe. For years after their initial discovery, these blips were thought to be one-off cataclysms, the final death cries of stars being shredded by black holes or the colossal collisions of neutron stars. A single, brilliant flash, and then nothing but silence, that changed with one specific burst, a source known as FRB 121102. Unlike any before it, this one did the impossible. It repeated. It was not a single cosmic detonation, but a source that could fire again and again, sometimes in frantic, unpredictable clusters, sometimes with a steady, almost rhythmic pulse. This single repeater shattered the simple cataclysm theory. How could a star blowing itself apart manage to do it multiple times? The existence of a repeater meant there had to be a source that could survive its own outburst, an engine that could power these immense explosions over and over again. The hunt was on to pinpoint where these bursts were coming from. Using the world's most powerful radio telescopes as interstellar triangulation devices, astronomers succeeded in tracing several of these repeating bursts back to their home galaxies. They did not originate in the empty void between galaxies, but from specific, often unremarkable, dwarf galaxies millions of light-years away. This localization was a monumental step, but it only deepened the mystery. We now knew where they lived, but we still had no idea what they were. The leading natural candidate is a specific type of neutron star called a magnetar. Imagine the core of a giant star crushed into a sphere the size of a city, yet weighing more than our sun. A magnetar is this, but with a magnetic field so unimaginably powerful that it could erase the data on every credit card on Earth from halfway across the solar system. Theorists suggest that starquakes on the surface of these magnetars, or sudden rearrangements of their impossibly rigid crusts, could release these titanic blasts of radio energy. It is a compelling idea, a natural cosmic engine of immense power. Yet some of the patterns are so strange, so seemingly structured, that the shadow of a far more speculative explanation still lingers. Could we be witnessing the leakage from unimaginably powerful alien technology? Perhaps these bursts are the side effects of light sails being pushed by giant radio beams, or signals meant for interstellar communication that we are only catching a fleeting, distorted glimpse of. While most scientists favor the magnetar model, the sheer raw power and bizarre repetition of fast radio bursts ensure they remain an open case. A reminder that the universe is capable of violence and mystery on a scale we are only beginning to perceive. While our telescopes listen for cosmic screams and whispers, a mystery was unfolding much closer to home, aboard two silent robotic ambassadors drifting into the void. The Pioneer 10 and 11 spacecraft, after completing their historic missions to Jupiter and Saturn, were now on trajectories that would carry them out of the solar system forever. Mission controllers, tracking their faint radio signals with exquisite precision, noticed something was terribly wrong. An unknown force was acting upon them, a tiny but relentless tug, slowing their journey into interstellar space. This was the Pioneer anomaly. The deceleration was minuscule, less than a billionth of the gravity we feel on Earth. But over the vast distances of space, this tiny effect accumulated into a massive discrepancy. It was as if you rolled a ball down a perfectly flat, endless hallway, only to watch it slow down and stop far sooner than every law of physics said it should. For decades, this stubborn drift defied all explanation, challenging our most fundamental understanding of gravity and motion. Was Newton's law of universal gravitation, the very bedrock of classical physics, breaking down at the edge of the solar system? Could Einstein's theory of general relativity be incomplete? The most tantalizing and terrifying possibility was that we had stumbled upon a new force of nature. The scientific community was captivated, and the hunt for an answer began. The most plausible explanation was not a new physics, but something far more mundane: thermal radiation. The Pioneer spacecraft were powered by radioactive plutonium, and the heat from these generators had to go somewhere. Perhaps the simple act of radiating heat away from the spacecraft was creating a tiny, unintended thrust, like the gentle push you feel when a warm object cools in your hand. For years, this was the leading theory, but proving it was a monumental task. The original engineering data was old, stored on outdated magnetic tapes, and the precise blueprints of the spacecraft's complex structure were scattered and incomplete. A dedicated team of researchers embarked on a digital archaeology project, recovering and analyzing decades-old data to build a complete thermal model of the Pioneers. They painstakingly calculated how every component, from the main antenna to the instrument booms, would have radiated heat into space. After years of work, they concluded that the gentle pressure of this escaping heat could, in fact, account for almost all of the anomalous deceleration. The case was considered closed by many, but a sliver of doubt remains. The thermal model is incredibly complex, and some argue that it cannot explain every last bit of the strange behavior. The Pioneer anomaly, even if mostly solved, stands as a profound lesson. It reminds us that our knowledge of the cosmos is built on measurement, and that even the tiniest, most unexpected deviation can force us to question everything we think we know, pushing our understanding of the physical world to its very limits. The Pioneer anomaly was a ghost in our own machine, but a far stranger visitor was already on its way. In October 2017, astronomers in Hawaii spotted an object moving at such a staggering speed it could only have come from beyond our solar system. This was Oumuamua, a messenger from afar, and it was unlike anything we had ever seen. Its trajectory was the first clue to its alien origin. It was not orbiting our sun, it was merely passing through, a cosmic tourist on a billion-year journey. The name Oumuamua, from the Hawaiian for scout or messenger, was perfectly chosen, but its path was only the beginning of the mystery. As telescopes around the world swiveled to observe it, they found it had no coma, the fuzzy halo of gas and dust that surrounds every active comet. It appeared as a bare, dark rock tumbling through the void, yet its light curve, the pattern of its brightness as it spun, revealed its most startling feature. It was not round. The changes in its reflected light were so extreme that the only plausible shape was a highly elongated one, like a cigar or a flattened pancake, with its length estimated to be up to 10 times greater than its width. Nothing in our solar system, no asteroid or comet, has such a dramatic proportions. This was a shape born in another star system entirely. Then came the final and most baffling piece of the puzzle. As Oumuamua sped away from the sun, something impossible happened. Its trajectory could not be explained by gravity alone. It was accelerating ever so slightly, as if an unseen hand was giving it a gentle push. For a comet, this is normal behavior caused by the rocket-like effect of vaporizing ice jetting from its surface, but Oumuamua had shown no signs of outgassing. No dust or gas was detected around it. It was accelerating like a comet, but it looked and acted like a barren asteroid. This non-gravitational acceleration defied all conventional explanation. One compelling theory proposed that Oumuamua was in fact a comet after all, but a very exotic one. Perhaps it was made mostly of solid nitrogen, like a giant chunk of dry ice. As the sun warmed it, the nitrogen would have sublimated directly from a solid to a gas, providing the thrust for its acceleration without releasing the dusty debris that telescopes could easily see. This would explain the push and its strange, shiny surface, as nitrogen ice is highly reflective. Yet the nitrogen iceberg model requires a very specific and rare birthplace, a Pluto-like world torn from its home system. The debate remains fierce. The most famous and controversial hypothesis came from Harvard astronomer Avi Loeb, who suggested that Oumuamua's peculiar acceleration and shape were consistent with a light sail, a piece of alien technology designed to be pushed by the radiation pressure from stars. Its flattened form would be ideal for sailing on starlight, and its lack of a visible coma or jet would be expected from an artificial object. While most astronomers consider a natural origin more likely, the true nature of Oumuamua is a secret it took with it back into the interstellar dark. It was a one-of-a-kind visitor, a preview of the countless strange objects that must drift between the stars, reminding us that our solar system is just one island in a vast and largely uncharted cosmic archipelago. Oumuamua was a solitary wanderer, a fleeting glimpse of the strange objects hiding in the dark. But that darkness itself holds the universe's most pervasive secret, a ghost that permeates every corner of space. We have mapped the cosmos, counted the stars, and weighed the galaxies, only to discover that everything we can see, every planet, star, and nebula, accounts for less than 5% of reality. The rest is darkness. The first compelling clue emerged from the spin of galaxies. When we observe a spiral galaxy like our own Milky Way, we expect the stars on the outer edges, far from the central bulge, to orbit more slowly, just as Pluto moves much more sluggishly around the Sun than Mercury does. But the data reveals something astonishing. Stars on the galactic fringe orbit at nearly the same incredible speed as those close to the center. It is as if the entire galaxy is embedded within an immense, invisible sphere of something, a halo of unseen mass whose gravity grips the outer stars, whipping them around to keep pace. Without this hidden mass, these distant stars would be flung off into the void, and the galaxy would tear itself apart. This invisible glue is dark matter. Further proof comes from one of Einstein's most spectacular predictions, gravitational lensing. Massive objects warp the fabric of space-time, bending the path of light that travels past them, acting like a cosmic magnifying glass. Astronomers see this effect constantly. They will observe a distant galaxy, but its light is stretched and distorted, sometimes split into multiple, shimmering arcs around an apparently empty patch of space. Something massive in the foreground is bending the light, but that something is completely invisible. It is the gravitational footprint of a vast cloud of dark matter, betraying its presence by the way it twists the very light of the universe. So what is this mysterious substance? It cannot be made of atoms, the stuff of stars and people. It does not emit, absorb, or reflect any form of light. It only interacts with the universe through gravity. The leading candidate for decades has been a hypothetical particle called a WIMP, a weakly interacting massive particle. These would be heavy, sluggish particles that barely interact with normal matter, streaming through our bodies and our planet by the trillions every second without a trace. Yet despite decades of searching with incredibly sensitive detectors buried deep underground to shield them from cosmic rays, we have not caught a single one. Another intriguing candidate is the action, a particle that is fantastically light but could exist in such overwhelming numbers that it accounts for the missing mass. Actions are theorized to be so ghostly that they could even convert into photons in the presence of a strong magnetic field. Sophisticated experiments are now hunting for this faint whisper of a signal. The enduring puzzle is why dark matter remains so stubbornly elusive. Its gravitational effects are undeniable, sculpting the cosmos on the largest scales. Yet it refuses to reveal its true nature in our laboratories. Is our understanding of gravity itself flawed on cosmic scales? Or are we simply on the cusp of a discovery that will shatter the standard model of particle physics and reveal an entirely new layer of reality, one made of a shadow substance that forms the true backbone of the universe? If dark matter is the invisible hand holding galaxies together, then dark energy is the phantom force tearing the entire cosmos apart. Its discovery was a shock that overturned a century of cosmic assumptions. For decades, astronomers believed the universe's expansion, a relic of the Big Bang, was gradually slowing down, restrained by the collective gravity of all the matter in existence. The ultimate question was whether that gravity would be strong enough to one day pull everything back together in a big crunch, or if the universe would simply coast forever into a cold, dark stillness. To find the answer, two independent teams set out to measure the slowing by observing distant stellar explosions known as Type 1, a supernova. These supernovae are cosmic standard candles, exploding with such a consistent, predictable brightness that by measuring how dim they appear from Earth, astronomers can calculate their precise distance. By comparing this distance to how much the light from the supernova has been stretched or redshifted by the expansion of the universe, they can determine how fast the universe was expanding at different points in the past. The results were not just surprising, they were revolutionary. The most distant supernovae were significantly fainter than they should have been, meaning they were much farther away than anyone had predicted. The expansion of the universe was not slowing down at all. It was speeding up. Some mysterious, repulsive force was acting against gravity, pushing galaxies apart at an ever-increasing rate. This was dark energy. The simplest explanation for this bizarre anti-gravity is something known as vacuum energy, an inherent property of empty space itself. According to quantum physics, a perfect vacuum is not truly empty, but is a seething foam of virtual particles that constantly pop in and out of existence. This quantum fizz is theorized to possess an energy that exerts a negative pressure, a kind of springiness to the fabric of space that causes it to expand. The problem is one of catastrophic proportions. When physicists calculate how much energy this quantum vacuum should contain, the number they get is wrong by a factor of 1 followed by 120 zeros. It is the most spectacular failure of a prediction in the entire history of science. This discrepancy means we are fundamentally missing something profound about the nature of reality. The implications are staggering. If dark energy continues to dominate, as all evidence suggests it will, the fate of the cosmos is one of increasing isolation and cold. Distant galaxies will eventually be pushed away so fast that their light can no longer reach us. The cosmic horizon will shrink, and any future civilization will look up at an empty, black sky with no evidence of a universe beyond their own galaxy. All traces of the Big Bang will be lost to them, and the story of a vast, expanding cosmos will fade into an unknowable myth. Dark energy is not just another mystery, it is the mystery that will dictate the ultimate end of everything. Dark energy dictates a future of endless expansion, but a single, strange chill in the ancient light of creation hints at a past just as bizarre. While mapping the faint afterglow of the Big Bang, the cosmic microwave background, astronomers stumbled upon a region so vast and so cold it defies easy explanation. This is the CMB cold spot, an immense patch of sky where the temperature is a tiny but significant fraction lower than the surrounding warmth. To call it cold is a relative term. We are talking about a variation in a background that is already only about 2.7 degrees above absolute zero. But in a universe that is supposed to be largely uniform, this anomaly is a screaming outlier. It is not a small blemish. This spot is a colossal void in the fabric of the cosmos, spanning nearly 2 billion light-years across. If you could see it with your naked eye, it would appear larger than dozens of full moons lined up in the sky. For such a massive cold region to exist purely by random chance is statistically almost impossible, like rolling a dice and getting the same number a million times in a row. So what could have cast such a giant shadow on the dawn of time? One leading theory is that we are looking at a cosmic supervoid, an unimaginably empty region of space where galaxies and galaxy clusters are strangely absent. As light from the CMB travels through such a void, it must climb out of this gravitational well. According to general relativity, light loses energy as it climbs away from a massive object, which causes its wavelength to stretch and become redder, an effect known as gravitational redshift. But in a void, the opposite happens. There is less gravity pulling on the light, so it actually gains a tiny amount of energy as it enters the void, and then loses that energy again as it exits. This integrated Sachs-Wolf effect would manifest as a slight cooling in the CMB, exactly as we see. The problem is one of scale. For a supervoid to cause the observed cooling, it would have to be so enormous and so empty that it challenges our understanding of how structures form in the universe. It would be the largest structure ever discovered, and finding one that big is in itself a profound cosmic mystery. The other, far more radical explanation is that the cold spot is not a feature of our universe at all, but a bruise. A scar left from a collision with another universe in the greater multiverse. In this mind-bending scenario, the cosmic inflation that created our universe is an ongoing process, with countless other bubble universes constantly budding off from an eternal cosmic landscape. If our bubble universe had brushed against another in the first instance of its existence, the energy of that collision could have drained away from a region of our cosmos, leaving behind this permanent cold spot in the background radiation. It would be the first observational evidence that our universe is not alone, but merely one bubble in a frothing metacosmic sea. The cold spot, therefore, is more than just a statistical anomaly. It is a potential window into the infinite, whether it is a vast, haunting emptiness or the fingerprint of a parallel reality. Its existence forces us to confront the limits of our models and the staggering possibility that the cosmos is far stranger and more vast than we ever dreamed. Our own moon holds a mystery as persistent as it is fleeting. For centuries, astronomers have documented strange, unpredictable lights and glows flickering on its surface. These are transient lunar phenomena, and they defy any simple explanation. These are not the steady gray plains we see on a quiet night. These are temporary flashes, crimson glows, areas of haze that obscure craters, and patches of color that appear and vanish within minutes or hours. One of the most famous sites of this activity is the crater Aristarchus, a brilliant white scar on the lunar surface that has been the source of hundreds of these anomalous reports. In the late 1960s, astronomers at the Lowell Observatory even recorded a bright red glow within the crater that lasted for over 20 minutes. Similar events have been seen in the craters Plato and Alphonsus, among others. These are not the fantasies of amateur stargazers. They have been witnessed by some of the most respected observers in history. So what could possibly be causing these ghostly illuminations on a world we thought was geologically dead? The most accepted scientific theory points to outgassing. The moon's interior may still hold trapped radioactive elements that slowly decay, releasing radon gas. When this gas seeps up through cracks in the lunar crust and is exposed to sunlight, it could theoretically cause the surface soil to fluoresce with a faint, eerie glow. Alternatively, the sudden release of a gas pocket could kick up clouds of incredibly fine dust, which could hover above the surface, temporarily obscuring the terrain below and appearing as a localized haze. Another likely culprit is the constant bombardment of meteoroids. When a small space rock strikes the lunar surface at tens of thousands of miles per hour, the impact vaporizes rock and soil in a flash of light intense enough to be seen from Earth. These impact flashes are real and are regularly recorded by NASA. Yet they are instantaneous, while many transient lunar phenomena are reported to last for much longer durations, glowing and pulsing in a way a single impact cannot explain. This leads to more speculative and far more intriguing possibilities. Could some of these events be linked to electrostatic activity? The Moon's surface is covered in a layer of sharp, abrasive dust that becomes electrically charged by the solar wind. Could this buildup of static electricity occasionally discharge in vast, silent sparks or cause the dust itself to levitate and glow? Or, in the realm of pure speculation, could we be seeing evidence of unknown geological processes, a form of cold volcanism or tidal heating that we do not yet understand? The profound difficulty in studying these phenomena is that they are, by their very nature, transient. They are unpredictable and often visible only through telescopes for a brief window of time. By the time multiple observatories can be pointed at the same spot, the glow has usually faded, leaving no trace behind. We are left with centuries of compelling anecdotes but a frustrating lack of hard, repeatable data. These flickering lunar lights remain one of the oldest and most intimate cosmic mysteries, a reminder that even our closest celestial neighbor, a world we have visited in person, still holds onto its secrets, glowing faintly in the dark just beyond our full comprehension. While our own moon flickers with transient mysteries, the planet Saturn presents a geometric wonder of breathtaking permanence. At its north pole, a storm rages that is unlike any other in the solar system, a six-sided jet stream known simply as the Saturn hexagon. This colossal structure is so vast that 4 Earths could fit side by side within its boundaries. It is not a feature painted on the surface, but a towering wave of wind, a hexagon-shaped hurricane spinning in perfect synchronization with the planet's rotation. Imagine a whirlpool in a draining sink, but one that has maintained a perfect hexagonal form for decades, possibly even centuries, its sides sharper and more geometric than anything nature should allow. The first hints of this anomaly came from the Voyager flybys in the 1980s, but it was the Cassini spacecraft that revealed the hexagon in all its terrifying glory, its cloud walls churning with immense storms and bathed in the changing light of Saturn's seasons. How can a fluid, chaotic atmosphere like Saturn's, a ball of raging hydrogen and helium, lock itself into such a rigid geometric pattern? The most compelling explanation lies in laboratory experiments with fluids. When a circular tank of liquid is spun at different speeds between its center and its outer edge, the fluid can spontaneously organize into polygons. The key is the speed gradient, the difference in rotation. On Saturn, deep below the visible cloud tops, there may be a colossal, hidden jet stream flowing at a vastly different speed than the upper atmosphere. As the planet's rotation shears this atmospheric soup, it can potentially create a standing wave pattern that manifests as this stable hexagon. It is like dragging a stick through a stream of water. Under the right conditions, the wake can form a series of stable, oscillating waves, and on a planetary scale, those waves have 6 sides. Another theory suggests this is the visible footprint of a deep, rotating cyclone, a storm so powerful and so stable that it imprints its geometric shape on the entire polar weather system. Yet, even with these models, the perfection and longevity of the hexagon are staggering. It is a lesson in scale, demonstrating that the physics we understand in a laboratory can, under the right conditions, create structures of unimaginable size and precision in the cosmos. The Saturn hexagon is a natural, fluid dynamic puzzle, a celestial signature written in the clouds of a gas giant, reminding us that order can emerge from chaos on a scale that defies belief. The flickering of Tabby's star captivated the world with the possibility of an alien megastructure, but the universe, as it often does, offered a more nuanced yet equally baffling truth. Newer observations from powerful telescopes, including Hubble, have meticulously analyzed the starlight during its bizarre dimming events. They found a crucial clue. The light was not being blocked evenly across all wavelengths. If a solid object like a planet or a vast solar panel were passing in front of the star, it would dim the star's light uniformly. Instead, the dimming was more pronounced in blue light than in red light. This is the classic signature of dust, tiny particles smaller than a grain of smoke scatter blue light more effectively, allowing redder light to pass through. So the mystery was solved, right? Not even close. While the dust discovery ruled out a solid Dyson sphere, it opened a far stranger and more complex puzzle. What kind of dust behaves like this? The dust around Tabby's star is not like the simple, uniform ring around Saturn. It is opaque, fine, and exists in a bizarre, clumpy, and asymmetric cloud. Think of it not as a smooth veil, but as a swarm of immense, irregular dust clouds orbiting the star in a chaotic and unpredictable dance. The central question now is, what is the engine creating this dust? A normal star would have a dust disk that is relatively even and predictable, the leftover debris from its planetary formation. But this dust is not playing by those rules. One leading theory suggests an ongoing cosmic catastrophe. Perhaps a moon or a planet was torn apart by the star's gravity, and we are witnessing the resulting cloud of pulverized debris as it slowly spirals inward, casting its vast, ragged shadows. Another possibility points to a colossal family of comets, but not just any comets. They would need to be on wildly eccentric orbits, breaking apart and releasing immense amounts of dust in short, violent outbursts. The sheer scale required, however, pushes the limits of plausibility. The dust itself is also a riddle. It is not replenishing itself. Detailed studies show that the smallest dust particles should be blown away by the intense radiation pressure from the star almost immediately. For the dust clouds to persist, there must be a continuous source, a factory that is constantly grinding larger objects down into this fine, opaque powder. We are left with a celestial detective story where the primary suspect has been identified, but its motives and methods remain utterly obscure. The star's light continues to waver, its strange dips and rises a silent testament to a cosmic process we have yet to fully comprehend. A reminder that nature's imagination often far exceeds our own. Far beyond the orbit of Neptune lies a frozen frontier, a vast disk of icy worlds known as the Kuiper Belt. This is the solar system's attic, filled with ancient relics from the dawn of planetary formation. Astronomers expected this debris field to gradually thin out, with smaller objects scattering into the deep freeze of interstellar space. But the reality is far more abrupt and puzzling. The Kuiper Belt does not fade away gently. It ends in a cliff. There is a specific distance from the sun where the population of these icy bodies plummets, as if someone drew a celestial border and swept everything from the other side clean. It is a sudden, dramatic drop in density that our current models of the solar system cannot explain. Why would a natural cloud of debris, shaped by billions of years of gravity, have such a sharp and definitive edge? One compelling theory points to the gravitational influence of a hidden giant. The shepherding effect is a well-known phenomenon in astronomy. We see it with Saturn's rings, where small moons orbit just inside or outside a ring, their gravity carving out sharp gaps and keeping the ring particles in a neat, confined band. On a vastly larger scale, a massive, undiscovered planet lurking in the distant dark could be acting as the solar system's ultimate shepherd. This hypothetical planet 9, with an orbit thousands of times farther from the Sun than Earth's, would exert a powerful gravitational pull on the Kuiper Belt objects. Its distant, slow orbit would carve out a clear boundary, scattering any objects that drift too close and shepherding the remaining debris into a sharply defined disk. The alternative explanations are equally intriguing. Could this cliff be a fossilized edge, a permanent scar from the solar system's violent birth? Perhaps it marks the precise boundary where the protoplanetary disk of dust and gas that surrounded our infant sun simply ran out of material. Or maybe it is evidence of a stellar flyby, a close pass by another star in our sun's early history that stripped away the outer reaches of the Kuiper Belt, stealing a portion of our solar system's primordial material. The hunt for the cause of this cosmic cliff is actively underway, driving a new era of deep sky surveys. Each new, distant object discovered adds another data point, another clue to the gravitational forces at play in the solar system's dark hinterlands. The Kuiper belt cliff is more than just an anomaly. It is a celestial signpost pointing toward a profound truth. Our inventory of the solar system is far from complete, and something immense may still be waiting in the shadows, its silent gravity sculpting the edge of our known world. Even the faint afterglow of creation itself seems to hold a disturbing reference to us. The cosmic microwave background is the oldest light in the universe, a baby picture of the cosmos from its first moments. The fundamental assumption of modern cosmology is that this background should be a random, featureless smear, the same in every direction with no preferred axis or special location. This is the cosmological principle in its purest form. Yet, when scientists created the most detailed map ever of this ancient light, they found something that should not be there. They called it the axis of evil. This is not a physical axis, but a bizarre and controversial alignment. The largest and most fundamental fluctuations in the cosmic microwave background, the hot and cold spots that seeded all the galaxies and voids we see today, appear to be subtly aligned with the plane of our own solar system. It is as if the universe's blueprint has a faint arrow pointing directly at us. This correlation defies all logic. According to the standard model, our position in the cosmos is utterly insignificant. The cosmic microwave background is a signal from the entire observable universe, from a time long before the Earth or the Sun existed. There is no possible reason for this primordial radiation to know or care about the flat plane in which our planets orbit. The chance of such an alignment happening at random is astronomically low. So what does this mean? The most unsettling possibility is that we are seeing a systematic error, a ghost in our own data. Perhaps the way we subtract the foreground glare of our own galaxy is inadvertently imprinting this solar system signature onto the deeper cosmic map. This is the hope of many scientists because the alternative is far more radical. If the alignment is real, it challenges the very foundation of the Big Bang theory and the cosmological principle. It suggests that the universe has a preferred direction, a fundamental lopsidedness that makes one axis different from another. Our place in the cosmos would not be random, but somehow linked to the largest scale structure of reality itself. This could point toward exotic physics, theories where the fabric of space-time is fundamentally twisted, or where our universe is but one bubble in a vast multiverse, its structure subtly warped by a collision with a neighboring cosmos. The axis of evil remains one of cosmology's most profound and hotly debated anomalies. It is a whisper that our most cherished assumptions about the universe's uniformity might be wrong, and that the cosmos in its deepest past may have been looking back at our future. Even the most chaotic stellar deaths can give rise to impossible geometry. Far from the haunting alignment of the axis of evil, a dying star system has sculpted a structure of such precise symmetry it appears crafted by an intelligent hand. This is the Red Rectangle Nebula, a cosmic jewel box located about 2,300 light-years away in the constellation Monoceros. Through the lens of the Hubble Space Telescope, it does not look like a typical billowing cloud of gas. It is a stark, angular form, an unmistakable X-shape, like a colossal hourglass or a pair of intersecting diamond rings, all bound within a framework of glowing, concentric rectangles. The effect is so unnervingly perfect that it feels more like a piece of cosmic architecture than a natural phenomenon. How can a star's death produce such rigid, linear beauty? The secret lies not in one star, but in a pair. The red rectangle is a binary system, two stars locked in a tight, intricate dance. One of these stars has reached the end of its life, swelling into a red giant and shedding its outer layers into space. Normally, this expelled gas would bubble out in a roughly spherical shell, creating a classic round planetary nebula. But here, the gravity of the companion star acts as a master sculptor. As the dying star expels its material, the smaller companion star orbits within that outflow, funneling the gas into two powerful, opposing jets. Imagine a spinning lawn sprinkler that sends out two strong, steady streams of water. Now imagine that sprinkler is not just spinning but also wobbling like a top beginning to slow down. This is precisely what is happening. The entire binary system is processing, meaning the axis of the jet slowly wobbles over a long period. As the jets wobble, they trace out a conical shape in space. From our vantage point on Earth, we are looking directly down the barrel of this cosmic hourglass. The intersecting cones of gas create the vivid X shape, while the concentric rectangles are actually the edges of these cones, like the ripples from a stone thrown into a pond, captured and frozen in luminous gas. The stunning red color comes from a specific type of carbon-rich dust, illuminated by the intense light of the central stars. This nebula is a temporary masterpiece, a fleeting alignment of orbital mechanics and stellar death. It shows us that the universe does not need a guiding intelligence to create structures of breathtaking order and symmetry. Sometimes all it takes is the perfect gravitational dance, a celestial partnership that writes its final chapter in geometry and light. The geometric perfection of the red rectangle nebula shows us how structure can emerge from chaos, but the cosmos is equally capable of creating voids of staggering emptiness. Looming in the constellation of Bootes lies one of the greatest nothings we have ever found, a spherical region of near-total emptiness so vast it could swallow thousands of galaxies whole. This is the Bootes Void, a cosmic desert spanning 330 million light-years. To grasp its scale, if you placed our Milky Way at its center, the next nearest galaxy would be so far away its light would take millions of years to reach us, leaving our night sky almost completely black. Voids are a natural part of the cosmic web, the empty spaces between the great filamentary walls of galaxies. But the Bootes Void is an extreme outlier, a hole in the universe so disproportionately large it challenges our understanding of how matter clumped together after the Big Bang. Current models of cosmic structure formation cannot easily account for a void of this magnitude. Gravity, over billions of years, should have pulled matter into these empty regions, slowly filling them in. The fact that the Bootes Void remains so profoundly empty suggests something prevented that infall, or that our models of how the cosmic web evolved are fundamentally incomplete. What could create such a vacuum? One theory posits that not one, but many smaller voids merged over time, like soap bubbles coalescing into one gigantic cavity. Another, more radical idea involves a phenomenon called cosmic inflation in the very early universe. Perhaps a rare, ultra-energetic fluctuation during that initial explosive expansion created a region of space that was stretched far more than its surroundings, resulting in this permanent, underdense bubble. The few galaxies that do cling to existence within the void are not scattered randomly. They huddle together in a few thin, filamentary structures, like survivors on isolated islands in an endless, dark ocean. These galaxies are themselves strange, often showing signs of stunted evolution, as if the profound isolation of the void has starved them of the galactic interactions that typically drive the formation of new stars. The Bootes Void is not just an empty space, it is a cosmic fossil. Its existence forces us to confront the limits of our knowledge, suggesting that the processes that shaped our universe may have produced extremes we are only beginning to map. It is a haunting reminder that the cosmos is defined as much by its immense emptiness as by its brilliant islands of light. Deep within the speculative frontiers of physics lies a concept so strange it challenges the very idea of what matter is. This is the realm of unparticle physics, a theoretical proposal suggesting that at very high energies, the universe might be filled with a form of matter that does not behave like particles at all. Unlike the familiar protons, neutrons, and electrons that make up our world, unparticles would have no definite mass. They would not be points, but rather smeared-out entities, scale-invariant ghosts that look the same no matter how closely you zoom in or out. Imagine trying to catch smoke with your hands. It has substance, it exists, but it possesses no solid edges or predictable shape, flowing and existing in a state that defies simple categorization. This is the ethereal nature proposed for unparticled stuff. The motivation for such a bizarre idea comes from trying to explain anomalies in the most energetic phenomena in the cosmos. Ultra-high-energy cosmic rays are a prime example. These are subatomic particles, often single protons, that strike our atmosphere with energies millions of times greater than anything produced in the most powerful human-built particle colliders. They should not exist. According to our current understanding, such immensely energetic particles should be slowed and absorbed over their long journeys across the universe by interacting with the cosmic microwave background radiation, an effect known as the GZK cutoff. It is as if a marathon runner should collapse from exhaustion long before the finish line, yet some are sprinting across it with energy to spare. Unparticle physics offers a potential, though highly speculative, escape route. If these cosmic rays were interacting not just with known particles, but with this background sea of unparticles, the rules of the game could change. The interactions could be different, allowing these ultra-high-energy messengers to travel much farther than our standard models predict. The evidence is far from conclusive, and most physicists view unparticles as a fascinating mathematical possibility rather than an established reality. Yet its very proposal highlights a profound truth. When our most powerful observations defy logic, when the cosmic data does not fit the model, it forces us to invent new concepts, to dare to imagine that the fundamental ingredients of reality might be far stranger and more fluid than we ever believed. At the very heart of our Milky Way, a silent, invisible storm is raging. From the region surrounding the supermassive black hole known as Sagittarius A star, telescopes have detected a mysterious and overwhelming glow of gamma-ray radiation, the most energetic form of light in the universe. This is the galactic center excess, a diffuse fog of high-energy photons that should not exist in such abundance. It is as if you were listening to a quiet symphony and suddenly heard a relentless, deafening drumbeat coming from the conductor's podium, a signal so powerful it drowns out all other instruments. For over a decade, astrophysicists have been locked in a fierce debate over the source of this bizarre energy. One compelling explanation points to the long-sought nature of dark matter. The center of our galaxy is thought to be densely packed with this invisible substance. According to some theories, when two dark matter particles collide, they could annihilate each other in a flash of pure energy, producing the very gamma rays we observe. This would be the first indirect detection of dark matter, a monumental discovery that would finally reveal the identity of the universe's primary architect. Yet, there is a formidable challenger to this idea. The gamma-ray excess could instead be coming from a vast, unseen population of pulsars. These are the rapidly spinning, city-sized cores of dead stars, which act like cosmic lighthouses, sweeping beams of radiation across space. A dense, spherical swarm of thousands of these faint pulsars, too dim for our telescopes to pick out individually, could collectively produce the exact same diffuse glow. It is the astronomical equivalent of standing far from a city at night. You see a general, uniform haze of light, but your eyes cannot resolve the individual street lamps and car headlights that create it. So how do we choose between a revolutionary new form of physics and a dense city of dead stars? The key may lie in the pattern of the light itself. If the glow is perfectly smooth and symmetrical, it favors the dark matter annihilation model. But if we can find tiny, point-like clumps within the haze, it would be the smoking gun for a pulsar population. Current data tantalizingly hints at such clumps, but the evidence is not yet conclusive. The debate rages on, a high-stakes scientific duel where the prize is nothing less than a fundamental rewrite of our understanding of the universe's hidden ingredients. The galactic center excess remains a siren song from the core of our home galaxy, a brilliant enigma that promises either a cosmic metropolis of the dead or the first ghostly whisper of the dark universe itself. While the galactic core hums with an unseen energy, certain stars wear their instability on their luminous sleeves. Luminous blue variables are the volatile titans of the stellar world, hypergiants so massive and unstable that their very existence is a temporary, violent spectacle. These are not the steady, predictable furnaces like our sun. They are cosmic pressure cookers perpetually on the verge of blowing their lids. A single one of these stars can outweigh our sun by over 100 times and shine with the brilliance of millions. They are rare, they are monstrous, and they defy every conventional model of how a star should live and die. Their defining characteristic is their wild, unpredictable personality. For decades, a luminous blue variable might shine with a steady, searing blue-white light. Then, without warning, it can undergo a colossal eruption. The star swells enormously, its outer layers becoming so distended that its surface temperature plummets, and its color shifts from a fierce blue to a cooler, redder hue. In these violent outbursts, it can eject more mass than our entire sun, hurling entire planets' worth of stellar material into space at phenomenal speeds. Imagine a star having a temper tantrum so severe it vomits a significant portion of itself into the void. This is not a gentle shedding of layers, it is a stellar catastrophe. The most famous example is Eta Carinii, a ticking time bomb in our own galaxy. In the 1840s, it underwent a great eruption that made it the second brightest star in the night sky for a time, despite being 7,500 light-years away. It ejected at least 10 times the mass of our sun, forming the beautiful bipolar homunculus nebula that now surrounds it, a cosmic monument to its own instability. Why do these stars behave so erratically? The sheer force of radiation pouring out from their cores is so immense that it battles directly against the star's own crushing gravity. This creates a state of precarious balance where the outward pressure of light almost, but not quite, overcomes the inward pull of mass. The star becomes bloated and unstable, its grip on its own outer layers so tenuous that any minor fluctuation can trigger a cataclysmic shedding of material. This bizarre life cycle makes them prime candidates for the most violent end of all, a supernova. In fact, many astronomers believe luminous blue variables are the direct precursors to a specific type of stellar explosion, a pair instability supernova, so powerful that it can completely obliterate the star, leaving no black hole or neutron star behind. It simply vaporizes itself in a final, defiant act of self-annihilation. These stellar behemoths live fast and die young, their chaotic lives challenging our textbooks and reminding us that in the cosmos, even the most fundamental laws can be stretched to their breaking point. A galaxy can be a ghost, drifting in the Coma Cluster some 300 million light-years away. Astronomers found Dragonfly 44, a cosmic wraith that should not exist. From a distance, it looks like a faint, smudged patch of light, a wispy cloud of stars so diffuse you could peer right through it. Its brilliance is a mere 1% of the Milky Way's. Yet, when scientists measured the motions of its scant stars, they found them whipping around at velocities that defied all logic. The tiny amount of visible matter in Dragonfly 44, the stars we can see, is nowhere near enough to hold the galaxy together. At the speeds those stars are moving, the galaxy should have flung itself apart eons ago. The only thing keeping it from disintegrating is an immense, invisible anchor, a halo of dark matter of almost unimaginable density. Calculations reveal a shocking truth. Dragonfly 44 is 99.99% dark matter. This is a place where the shadow universe has taken concrete form, a dark matter galaxy that just happens to have a few stars sprinkled within it as an afterthought. Think of it as a city where you can only see a handful of scattered, flickering street lamps, but you can feel the immense pressure of a colossal, invisible crowd moving all around them. This discovery shatters our standard models of galaxy formation. We thought galaxies began their lives as halos of dark matter, whose gravity then attracted the gas to form stars. But in Dragonfly 44, that process seems to have stalled almost completely. Why did so few stars form here? Was the primordial gas ripped away by the fierce gravitational tides of the cluster? Or does dark matter itself behave differently in certain environments, failing to ignite the stellar fires? Dragonfly 44 is not alone. Other ultra-diffuse galaxies with similar ghostly properties have been found, suggesting that dark matter can build structures entirely on its own, creating invisible frameworks across the cosmos. This raises a profound question. How many of these dark galaxies are floating in the void, completely invisible to our telescopes, their presence known only by the subtle warping of spacetime? Dragonfly 44 is a stark reminder that the universe we see is merely the glittering decoration on a hidden architecture of immense and mysterious scale. These cosmic rays carry more punch than any particle accelerator on Earth could ever hope to generate. A single proton, a minuscule speck of matter, arrives with the kinetic energy of a professionally thrown baseball, all compressed into a subatomic point. This should be impossible. According to a fundamental limit in physics known as the GZK cutoff, such ultra-high energy particles should be battered and slowed to a crawl over their million light-year journeys. They should collide with the photons of the cosmic microwave background, the faint relic radiation from the Big Bang that fills all of space. Think of it like a marathon runner trying to sprint through a dense, persistent fog. They should be exhausted and stopped long before reaching the finish line. Yet here they are, striking our atmosphere with undiminished fury. So where is their cosmic cannon? The hunt for the source of these phantom bullets has been one of astronomy's most frustrating challenges. Their rarity is one issue, with only a handful of these extreme events recorded per square kilometer per century. But the greater problem is that they are charged particles. Protons and atomic nuclei are deflected by the magnetic fields that weave through interstellar and intergalactic space. By the time one of these rays reaches us, its path is so scrambled that pointing back to its origin is like trying to trace a single raindrop in a hurricane back to the exact cloud it fell from. The mystery deepened when astronomers finally managed to triangulate the arrival directions of the highest energy events. They did not point to the obvious cosmic powerhouses, the brilliant quasars or violent gamma-ray bursts. Instead, they seemed to come from empty voids, the vast and relatively empty spaces between the great filaments of the cosmic web. It is as if the most powerful bullets in the universe are being fired from the deepest, darkest stretches of nothingness. This has led to truly radical theories. Could these particles be the decay products of super-heavy dark matter, weighing 1,000 times more than any known particle, finally disintegrating in the emptiness of intergalactic space? Or are they the signature of cosmic defects, topological kinks in the fabric of spacetime left over from the universe's first instance, unraveling and releasing colossal bursts of energy? The most profound possibility is that this is a sign of entirely new physics, a breakdown of Einstein's special theory of relativity at these unimaginable energies. The existence of these rays is a direct challenge, a cosmic dare from the void, forcing us to question whether we truly understand the rules of the game. A ghost passed through the Earth in September 2017. It was not made of atoms or light, but was a neutrino, a fundamental particle so ethereal that trillions stream through your body every second without a single interaction. This one was different. It carried an unimaginable energy, and it did not arrive alone. Deep inside the ice of the South Pole, the Ice Cube Neutrino Observatory, a cubic kilometer of pristine ice laced with sensitive light detectors, recorded the faint blue flash as this single neutrino slammed into an atomic nucleus. This precise timing and direction were the first crucial clues. Almost simultaneously, telescopes across the globe and in space detected a brilliant flare of gamma rays from a distant object known as Blazar TXS 0506+056, a cosmic beast located 4 billion light-years away. The coordinates matched perfectly. For the first time in history, we had caught a ghost and traced it back to its lair. A blazar is one of the most violent objects in the universe, a supermassive black hole at the heart of a galaxy, feasting on an immense disk of spiraling gas and dust. As material falls in, it is heated to billions of degrees and blasted out in two opposing jets of radiation and particles traveling at nearly the speed of light. We on Earth have the staggering fortune to be looking directly down the barrel of one of these jets, making it appear as a brilliant, variable point of light, a blazar. The detection of this high-energy neutrino from TXS 0506+056 was a landmark discovery because it finally confirmed a long-held theory. These monstrous engines are natural particle accelerators of almost inconceivable power. The same magnetic processes that create the jet must be able to accelerate protons to energies far beyond anything we can create on Earth. And when these ultra-high energy protons collide with other particles within the jet, they shatter, creating a shower of secondary particles, including the very neutrinos we can detect. Think of a colossal hadron collider, but one the size of a galaxy powered by a black hole and firing its beams directly at our planet. This single event opened an entirely new window on the cosmos, neutrino astronomy. We are no longer limited to observing the universe only through light, radio waves, or gamma rays. We can now use these nearly massless, chargeless messengers to probe the deepest, darkest hearts of cosmic monsters, regions so dense with matter and radiation that even light cannot escape. Yet for every mystery solved, a deeper one emerges. The extreme physics required to produce a neutrino of such energy pushes the limits of our understanding. How exactly are particles accelerated to such fantastic speeds within the jet? What are the precise chain of collisions and decays that create the neutrino signal? The detection was a triumph, but it also highlighted how much we still have to learn about the most energetic engines in creation, proving that even the most ghostly of cosmic messengers can point directly to the universe's greatest violence. A perfect circle of stars drifts in the cosmic dark, a celestial smoke ring of breathtaking symmetry. This is Hoag's object, a galaxy that appears to be almost entirely composed of a luminous blue ring of young stars, encircling a core of older yellow stars with a seemingly empty gap of blackness between them. It is a structure so geometrically ideal it looks artificial, a piece of cosmic art that defies the chaotic, spiral-armed norm of most galaxies. The formation of such a ring galaxy is a violent cosmic accident. The leading theory is a galactic bullseye, a precise head-on collision where a smaller galaxy pierces the heart of a larger disk galaxy. The impact sends a powerful density wave rippling outward through the disk like a stone dropped in a pond. This wave compresses the gas and dust as it travels, triggering a firestorm of new star formation in its wake. The result is a brilliant, expanding ring of young, hot blue stars, while the central core of the older galaxy, largely undisturbed by the collision, is left behind. It is a stellar tsunami, freezing a single, cataclysmic moment in time as a perfect circle of light. Yet this elegant explanation is not without its own profound puzzles. The ring of Hoag's object is almost perfectly circular, and it has maintained its stunning symmetry for hundreds of millions of years. One would expect such a structure to gradually distort, to develop instabilities and kinks as it evolves, yet it remains pristine. Furthermore, what happened to the smaller galaxy that caused the impact? There is no obvious culprit, no galactic wreckage left at the scene of the crime. It seems to have vanished, either fully absorbed or flung away into the intergalactic void. This raises a tantalizing question. Could some ring galaxies form through a different, more internal process, perhaps through a massive, unstable bar of stars at the center that later collapsed, sending out ripples of its own. The perfection of these cosmic rings challenges our understanding of galactic dynamics, suggesting that the aftermath of a colossal collision can sometimes produce an order more beautiful and enduring than the original galaxies themselves. They are rare, fleeting jewels in the cosmos, reminding us that from chaos can emerge a strange and lasting harmony. A cosmic bullet is screaming through the wreckage of its own birth. The neutron star, known as PSRJ 0002+6216, is not merely drifting through space, it is being violently ejected, racing away at a speed of 2.5 million miles per hour. This velocity is so immense that it could travel the distance from Earth to the Moon in a mere 6 minutes. Behind it, the star trails a brilliant 13-light-year-long tail of energized particles and magnetic fury, a cosmic contrail that points directly back to the scene of the crime. Astronomers have nicknamed this object the cannonball pulsar, and its existence challenges our understanding of how stars die. Neutron stars are the dense, collapsed cores of massive stars that have gone supernova. Usually, the titanic explosion is roughly symmetrical, and the resulting neutron star gets a gentle, lingering kick from one side of the blast, exploding with slightly more force than the other. But the cannonball pulsar did not get a gentle push, it was shot from a cosmic cannon. The sheer violence of its kick suggests that its supernova was profoundly lopsided, a catastrophic detonation that focused its energy in one specific direction, firing the stellar remnant like a bullet from a rifle. Think of a balloon that you release without tying the neck. It flies wildly around the room as the air escapes. Now imagine that same balloon, but with all the air forced out of a single, perfectly formed nozzle, launching it in a straight, precise line at impossible speed. That is the kind of focused, directional power we are talking about on a stellar scale. The pulsar's immense tail acts as a perfect pointer, a forensic clue leading back to the center of the supernova remnant that birthed it. Calculations show it has already traveled over 50 light-years from that point, moving so fast it will eventually escape the Milky Way galaxy entirely, doomed to wander the intergalactic void forever. The central mystery remains: what could cause such an asymmetrical explosion? One theory points to incredibly powerful magnetic fields generated deep within the dying star, fields that could channel the explosive force into two opposing jets. If one of these jets was significantly more powerful than the other, it could rocket the core away with the force we observe. Another possibility involves a complex dance of neutrinos, the ghostly particles that carry away 99% of a supernova's energy. If the flow of these neutrinos became uneven, it could create a recoil effect powerful enough to launch the neutron star on its incredible journey. The cannonball pulsar is a permanent exile, a runaway remnant whose incredible speed is a silent testament to the chaotic, violent, and still mysterious forces that govern a star's final moments. Our cosmic inventory has just faced a shocking shortfall. We have mapped the stars and galaxies, but when scientists added up all the normal matter in the universe, everything made of atoms, the numbers did not add up. Over half of it was simply gone. This is the missing baryon problem, a glaring hole in our accounting of the cosmos. Baryons are simply the particles that make up the familiar world, protons and neutrons, the building blocks of atoms, planets, and people. Based on precise measurements of the cosmic microwave background, the afterglow of the Big Bang, we know exactly how much of this normal matter the universe should have created. Yet for decades, when we counted everything we could see, from the brightest galaxies to the faintest gas clouds, we only found about 2/3 of it. A third of the universe's ordinary matter was unaccounted for, a ghost in the cosmic ledger. Where could an entire third of all atoms possibly hide? The answer was not in the bright islands of galaxies, but in the dark oceans between them. Theorists long suspected the missing matter was spread through the cosmic web, the vast filamentary structure of dark matter that connects all the galaxies in the universe. They predicted that these filaments were not empty. They should be filled with a diffuse, searingly hot gas, a plasma so tenuous and so hot that it is virtually invisible to our telescopes. This is not a gentle mist, but a raging intergalactic fog heated to millions of degrees. At such extreme temperatures, the gas does not emit the kind of light our optical telescopes can easily detect. It glows faintly in high-energy X-rays, but the signal is incredibly weak, like trying to spot the heat of a single candle from miles away. The breakthrough came when astronomers used a clever trick of cosmic backlighting. They did not look for the filaments themselves, but for the subtle shadow they cast on the most powerful light sources in the universe, distant quasars. As the brilliant light of a quasar travels for billions of years to reach us, it passes through these invisible filaments. The superheated gas in the filaments absorbs very specific wavelengths of this light, leaving a distinct fingerprint, a set of absorption lines in the quasar's spectrum. It is like analyzing the light from a distant lighthouse through a specific, invisible fog. The fog leaves a unique chemical signature in the light, proving it is there. By painstakingly combining data from hundreds of thousands of quasars, astronomers finally confirmed it. The missing baryons were there all along, woven into the cosmic web in the form of these incredibly diffuse, incredibly hot filaments of oxygen gas. We now know the universe's ordinary matter is not missing. It is just hiding in plain sight, a thin, hot soup that fills the spaces between the galaxies, completing the map of our cosmic home. Even our most trusted cosmic lighthouses are beginning to flicker with doubt. For over a century, a specific class of pulsating stars known as Cepheid variables has been the bedrock of the cosmic distance ladder. These stars are the universe's standard candles, their rhythmic brightening and dimming providing a reliable way to measure vast intergalactic distances. Their pulse is their power. The very physics of these stars creates a tight, predictable relationship between their intrinsic brightness and the period of their pulsation. A slow, majestic pulse means the star is incredibly brilliant, while a rapid, frantic flicker indicates a more modest glow. By observing this pulse rate from Earth and measuring how dim the star appears, astronomers can calculate its distance with remarkable precision. It is this very method that first allowed us to measure the scale of our own Milky Way and discover the expansion of the universe itself. But now, some of these celestial metronomes are skipping a beat. Certain Cepheids scattered across different galaxies are displaying anomalous behaviors. Their pulsations are not quite as regular as the models predict, or their brightness fluctuates in subtle, unexpected ways that the textbook equations cannot fully explain. It is as if a collection of the world's most precise clocks suddenly began to run at slightly different speeds for no apparent reason. The implications are profound because these stars are the fundamental rungs on the ladder we use to measure the Hubble constant, the rate of the universe's expansion. Any error in our understanding of Cepheids creates a ripple effect of uncertainty that travels all the way up to our largest-scale cosmological models. So what is causing this stellar misbehavior? One compelling possibility is the presence of unseen companions. Many stars live in binary systems, and if a Cepheid is dancing with a faint, hidden partner star, their gravitational tug of war could subtly influence the pulsations we observe, throwing off our precise measurements. Another, more intriguing idea is that we are seeing the effects of unknown stellar physics. The interiors of these giant, pulsating stars are realms of extreme conditions, and our models of how energy travels from their cores to their surfaces might be incomplete. Perhaps there are complex magnetic fields or unusual chemical compositions at play that we have not yet accounted for. This is not merely an academic curiosity. The persistent tension in measurements of the universe's expansion rate, the Hubble tension, might find its root in this very problem. If our fundamental distance markers are not as reliable as we thought, then our entire map of the expanding cosmos may need a subtle but crucial recalibration. The anomalous Cepheids whisper a cautionary tale from the void, reminding us that even our most trusted guides can hold secrets, and that the universe's greatest distances are measured with stars that still have something to teach us. The universe's densest objects might hide a secret far stranger than we imagined, deep within the crushing heart of a neutron star, where a sun's worth of mass is compressed into a city-sized sphere. The very nature of matter could be undergoing a terrifying transformation. This is the strange star hypothesis, a theory that proposes some neutron stars are not made of neutrons at all, but of something more fundamental and bizarre, strange matter. Normal matter is built from protons and neutrons, which are themselves composed of up and down quarks, the building blocks of our reality. But under pressures so immense they defy earthly physics, these quarks might break down into a new, stable state, a soup of up, down, and strange quarks. Think of it like a diamond. Under normal conditions, graphite is stable, but apply immense heat and pressure, and its carbon atoms rearrange into a diamond, a more stable and durable form. Strange matter could be the diamond of the subatomic world, the true and ultimate ground state of matter. If this is true, a strange star would be the most perfect, indestructible object in the universe, a single, gigantic atomic nucleus. How could we possibly spot such an object? The key lies in its unique birth and death. A strange star could be born in the supernova of a massive star, or it could form when a regular neutron star accumulates enough mass to trigger the phase transition, its entire being converting into this exotic substance in a strange quark nova. The observational signature of such an event would be a specific, fleeting flash of light and a burst of certain particles. Furthermore, strange stars would be slightly smaller and denser than their neutron star counterparts. Precise measurements of a pulsar's radius, perhaps from a next-generation X-ray telescope, could reveal an object so compact that only strange matter could explain its existence. The most unsettling implication, however, is that strange matter could be infectious. A single fragment or strangelet ejected from such a star during a collision could theoretically strike a normal neutron star or even a planet like Earth. Upon contact, it would convert the normal matter it touched into more strange matter, transforming the entire object in a chain reaction. It is a hypothetical cosmic contagion, a rewriting of reality at the most fundamental level. While there is no evidence this has ever happened, the mere possibility that the cores of these dead stars are not just dense, but are made of an entirely new, more stable state of existence, challenges our understanding of physics itself. At the very foundation of modern cosmology, a crack has appeared, and it is widening with every new observation. This is the Hubble tension, a stubborn and growing discrepancy in one of the most fundamental numbers in the universe, the Hubble constant. This constant is the universe's current rate of expansion, a single value that tells us how fast galaxies are receding from us at any given distance. For decades, we assumed there was one definitive answer. Now we are finding two, and they refuse to agree. The first method uses the cosmic microwave background, the ancient afterglow of the Big Bang, as a time capsule. By meticulously mapping the subtle fluctuations in this primordial light, scientists can project the universe's early conditions forward through 13.8 billion years of cosmic evolution, using our well-tested standard model of cosmology. This calculation provides a precise, albeit indirect, measurement of the Hubble constant. The second method is more direct, measuring the expansion rate using what we see in our modern cosmic neighborhood. Astronomers observe the pulsing of Cepheid variable stars and the brilliant explosions of Type I, a supernova in relatively nearby galaxies. By knowing the true, intrinsic brightness of these standard candles and measuring how dim they appear, they can calculate precise distances. When combined with measurements of how fast those galaxies are moving away from us, they arrive at a direct, local value for the Hubble constant. The problem is stark: the two numbers are irreconcilable. The pristine early universe method gives one answer, while the local present-day universe method gives another that is significantly faster. This is not a small margin of error. It is a persistent and statistically significant gap that has survived over a decade of increasingly precise measurements. It is as if you calculated how fast a car should be going based on the power of its engine and the incline of the road, only to look at the speedometer and find it is moving considerably quicker. One of these measurements must be wrong, or our understanding of the journey itself is flawed. The implications are profound. If the local measurement is correct, it suggests that our standard model of cosmology, the very one that perfectly describes the universe's infancy, is missing a crucial ingredient. Perhaps dark energy is not constant but has been strengthening over time, giving the expansion an unexpected extra push. Or maybe there is a new type of neutrino or another exotic particle from the early universe subtly altering the cosmic recipe. If the cosmic microwave background measurement is correct, then there may be an unknown systematic error in our local distance measurements, implying that our most trusted cosmic lighthouses, the Cepheids and supernova, are not as standard as we believed. The Hubble tension is more than a technical disagreement. It is a direct challenge to our story of the cosmos. It forces us to confront a humbling possibility that after centuries of observation, we may still lack a complete picture of the fundamental forces and components that have shaped our universe's destiny from its first breath to the present day. From the ghostly whisper of the wow signal to the unsettling pull of dark flow, our journey through these 30 cosmic enigmas reveals a universe far stranger than we ever imagined. We have stood before the silent, geometric perfection of the Red Rectangle Nebula and peered into the profound emptiness of the Boots Void. We have chased phantom particles from blazars and questioned the very stability of our cosmic lighthouses. Each discovery, from the infectious possibility of strange matter to the stubborn disagreement over the universe's expansion, is a crack in the foundation of our understanding. These are not mere puzzles to be solved. They are fundamental challenges, forcing us to rewrite the rules of physics and reconsider our place in the cosmos. They highlight a thrilling and humbling truth that we are only at the very beginning of a grand exploration, peering into a darkness teeming with secrets. The greatest breakthroughs in science have always come from confronting the inexplicable. So we turn this final question to you. Which of these cosmic mysteries keeps you awake at night, staring at the stars and wondering? Share your thoughts and never stop asking what else is waiting for us in the great dark ocean.